I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast.
Hey Ben.
Hey Matt.
You've got a new microphone.
I do. I have a lot of new things. I have so many new things today.
And we're going to find out in the edit whether or not this microphone actually works or not. So we're going to talk for like 45 minutes. And hopefully there's just more than silence on your side when we come to look at the recording.
Yes. I mean, I'd say, one chance in three.
Yeah, I'll take those odds.
Yeah. I have a whole new setup in lots of ways. I have a new podcasting setup here with the microphone. I have a new work laptop that for the first time since 2010, my primary work computer is not a Linux computer.
Wow.
And this is like a whole new world for me.
That's
I'm still deciding if I like it or not, but
that is an interesting. We'll have to dig into that because,
yeah.
I also have switched to a Mac.
Oh wow.
A few months back, but that was out of sort of a practical consideration of like I didn't like being one of the strange people at the company who didn't have a Mac, and so begrudgingly I accepted the corporate Mac and all of the things that come with the manageability,
the corporate machinations.
Oh, ow!
I'm sorry, I'll leave now.
Yeah, no, but all of the, I understand why if you're a company, particularly one like ours with the kind of intellectual property considerations and things, you want to have a machine that isn't just kind of a free-for-all. And so there's a certain amount of manageability and ensuring of encrypted hard diskness and all that kind of stuff, which, Ubuntu lags behind, understandably, compared to, a full operating system like Mac. Sorry. It's not a full operating system, but like a corporate-friendly operating system.
Yeah, a corporate-friendly operating system, which is weird because it didn't used to be like that.
Right.
Right? It used to be sort of like so the last time that I didn't have a Linux computer as my main computer was 2009,
right,
when I was consulting. And basically my choices back then, if I wanted to, as a consultant, sort of go into a random company that I had no idea who they were going to be, and have any sort of hope of connecting to their local network and, being able to share a presentation. The choices were a Windows laptop, which absolutely not, and a Mac. And so that's really the last time that I have used a Mac as my sort of primary laptop, my primary work laptop. And that was, for consulting reasons.
Got it.
Fast forward 13 years and now I'm kind of back to that. But yeah, like you, I had this sort of, because we started at our current company sort of very early on, and it's like, what's the policy on work laptops? It's like, well,
you should have one.
You should have one. Do you own one already? Well, maybe use that one for now, and then we'll get you a real one later.
That's right.
Right?
And we both managed to sort of wangle essentially a pick your own adventure laptop from like, here's a budget, go get a computer. We're like, sure, fine, whatever. We both. No, I ended up with a one of the Lenovo Carbon X series, which I've been very happy with. But I think you had something different, didn't you, from that point of view?
I had that one for a good long while.
Oh, okay.
And then and I had some problem with it. And then about 9 months ago, I switched over to like a Dell Inspiron, which was fine. It's a perfectly reasonable laptop. I enjoyed using it. And then, like you, I was like, this is like, I'm kind of grandfathered in here and I don't want to like spend a whole bunch of time reconfiguring everything, but, I probably should switch at some point. And then someone on my team went and took the project that we're working on and built it on a Mac and ran the tests, and the tests ran in half the time. And I said, we're switching right now.
So true to form, it was testing that got you to switch computers, whereas for me, it was just,
50% of the original, like twice as fast, it's sold. Where do I sign up? Right.
So we're gonna have to talk about how on earth that could be the case and how you're even able to do that because like my stuff, so like the way that I use my computer is a very, very much glorified thin client to a real
Mm-hmm.
Linux machine that lives in a data center somewhere and has all the CPUs and all the RAM and all the
Mm-hmm.
network connectivity for all the weird things I need it to have, which
Yeah.
I can't
Yeah.
get on a laptop, and I can't even get on Wi-Fi for some of the things that I have to be able to run and debug and whatever. So it makes sense to have a machine
Right.
somewhere else, and it's kind of nice to be able to say, "Can I have more RAM?" And someone clicks a button, and I have more RAM, as opposed to
Mm-hmm.
someone coming around with a stick of RAM and sort of saying, "We need to power down your machine." So that's cool. That's cool. There's manageability aspects there, but then the Mac to me is just a sort of an encumbrance that once I've got it configured correctly, doesn't get too much in the way for my full screen Linux desktop that I'm actually working
Right.
on.
Right. Uh-huh.
But so I never do anything locally. I have like 2 or 3 things
Yes.
installed locally, and that's it. But you're now saying that you're running on a Mac.
Yes. Yes. So this is different. Yeah. So, and I have kind of used the sort of like Mac as a dumb terminal in some situations, in the last few years. And, I think it works okay. It works fine. It is like kind of like it makes me a little sad that you've got this incredibly powerful machine that you're basically just using to shuffle pixels back and forth.
Right.
But aside from that, like it works great. But the things that we were seeing, is with the tests that we were running. I'm gonna have to explain a little bit of context here,
Yeah.
unfortunately, to really make this make sense. But I guess that's the point of this podcast. Um,
Wait, we have a point?
I
I thought the point was just,
News-
every Friday afternoon you and I get to hang out and not feel too guilty about it.
News to me, right? Wait, we're trying to do something here. So the thing with the tests in this project is that they are at a very particular sort of like phase in the
Mhm.
project. So the way that I think about as software projects grow, you measure them by things like complexity, and 2 ways I think, and capabilities. And 2 ways to sort of measure those things is like how many lines of code do you have and how many tests do you have, and sort of like if you're building things at least the way that I espouse them to be built, you wind up being able to run your tests, hundreds of tests per second, right?
Mhm.
And so what that gets you are some sort of like interesting metrics that you can look at and see like where are we in like the lifetime of this project, right? Because when you're in very early stages and you've got like 100 tests or 200 tests, they should be able to run basically instantaneously, right? Like on a single thread, right? Like you should
Okay.
have
Yep.
to do no additional work, no special tricks to get your tests to run in a second or less, right?
And this is because of all the things that you talk about in terms of making tests targeted. So one test in your instance might be something like take a list, add an element to the list. Is that element in the list? Yes. Okay. That's
Yeah.
one whole test, right? And then you've got a
Mhm.
different test and another test and another test so that you can, it's isolated. This isn't a test of like the test is do a comprehensive try of every possible combination of operations on a list. That's not a test. That's
Right.
yeah.
Right. If you were running a test like that, you would be running it in a different environment probably. You'd be running it in CI. And honestly, like,
And that's
I don't
more of a
even
sort
want
of
to,
property-based test type thing as well, where you're like trying to, but you're talking
or
about
even
like
a
unit
test where you're
tests.
like, yes, exactly.
Yeah.
Like even a test where you're like spinning up a database or something and doing a bunch of all of those kinds of tests. I write them very infrequently, first of all, and even if I did, I wouldn't run them in this way.
Got
right?
it. This is very much, I'm with you. Keep going.
Yeah, yeah. So you've got like, hundreds of these small, focused, fast tests, right? And then the software gets bigger and bigger and bigger. And then you eventually have like tens of thousands of these tests. Maybe you have like 10,000 of these tests. And at that point, even with very well-written tests, that you're sort of crossing a boundary there. I think we've talked about on the show before sort of the rule of eights.
Yes.
And
one of the earlier episodes, in fact.
Yes,
yeah.
Exactly. And you've got like when you're in that early phase and you got like 100 or so tests, maybe they'll run in like 800 milliseconds, and that might as well be instantaneous for the purposes of developer workflow, right? And then when you start to get up into like the thousands of tests, even if they're well written, they start getting closer to that like 8-second range, maybe even 10 seconds, 20 seconds, and you stop being able to work interactively. right? So as you make the transition from point 8 to 8, you can still work interactively. As you get beyond that phase, as you get beyond the sort of 10,000 tests phase, you stop being able to work interactively. Now, you can put that off a little bit longer by running your tests in parallel,
Right.
right?
Yeah.
Because at that point, the overhead of distributing the work of the tests is worth it. And so, because right now, if I run my tests in parallel on this project, it gets slower because the overhead of distributing them across
is actually
multiple
greater
cores,
than the fact that each test takes less than a couple of hundred microseconds even. Right.
Exactly. And the overhead of doing all of that just slows it down so much that it makes it slower. And so, but once you get up into the sort of 10,000, 20,000, 30,000 tests range, then you can scale across multiple cores and still sort of be in that 8-second feedback loop range, right?
Got it. Yeah.
So, and you can keep going with this, and that might even be a whole other episode talking about the other levels beyond that. But
yep.
But where we are right now with this project is the tests run fastest on a single core, right? And so I was talking to a bunch of our infrastructure folks, and I was like, hey, so our tests are taking like 10 seconds now. Can we just throw hardware at this problem and make it faster? And they're like, yeah, we can give you as many cores as you want. And I'm like, well, yeah, but that doesn't help. So we ran some tests. So on our sort of like remote desktop setups,
yep,
the tests that we currently have take 12 seconds. I think we've got, and that's including some integration-y style tests, but they take about 12 seconds. On my Linux laptop, they took 9 seconds. So they're actually faster on the Linux laptop. Which
that is very interesting. Yeah.
On the MacBooks, they take 5 seconds.
That is impressive.
And so this is basically like doubling the lifetime that we get to live in this, not quite honeymoon phase, but this like very interactive, simplistic world where all of our tests run in a single thread. You run all of them on every change. They're nice and fast, and you get to work in this iterative style. And so we've been working on this project for about 15 months now. And basically by doing this, I'm kind of like buying myself another 15 months.
I guess so. You double the speed unless you increase the size of the team and the output or whatever. If anything, you would have maybe asymptotically slow down or something,
Yeah. But then there's also, and this is especially true with Java, there's sort of a fixed overhead for running sort of like any non-trivial number of tests, right? You're probably going to spend, somewhere in the order of a second or two, just like loading all the classes and starting up the JVM.
Right.
All of those
and I suppose that's definitely worth saying, right? So that was a thing I was going to ask you about is like, how are you able to take the tests that you're going to be running in our big fat infrastructure that's all x86y, is all like big server class machines, run it first of all on your laptop, like natively, and secondly, then switch your laptop out for a completely different type of computer, and you've kind of given it away there. It's you've moved to Java, or this is all in Java.
This project has always been in Java.
A long time ago we had a big old discussion on this very podcast about when you should pick C++, when you should pick Java, when you should have Python or whatever. And I think although something like Python, which a lot of the code base that our company has is written in, is processor agnostic. Every library that Python uses is not agnostic, so we would probably have difficulty running, even like if it was Python, the kind of quanti mathy Python code that our folks write wouldn't run on a laptop without an ARM-based laptop like the Apples are, but Java just does, it seems.
Yeah, right. Exactly. Yeah, all the work that I've been doing, I basically spent this whole week. This is I'm going to give away our time here, but like we're sort of at the end of the year. Things are a little slow. We finished everything that we needed to do for the year. And I'm like, all right, I'm going to take this week. I'm going to move things over. And none of the Java code had to change at all. Actually, that's not true. There was one thing. There was one thing that I needed to change, which is some extended socket options that I had on a TCP socket, which were not supported on the Mac.
Right, but that's presumably a very straightforward if statement or whatever. You kind of accept that. Now, I remember talking, in fact, when we were talking in the episode C++ versus Java, I think we were talking a little bit about some of the previous attempts that we had. And other companies where I'd worked with folks who were like, hey, yeah, if it's in Java, then I can run it on my Mac, was exactly what happened there. This was before it was ARM-based, whatever. And I'm like, sure, but the first time that there is a bug in the native code that doesn't compile on your Mac because it's a different operating system or whatever, then I'm tapping out of this because I don't have the time to support two operating systems, however similar they are. And, obviously Mac OS and Linux are fairly similar as they go. It would be very different maybe if it was Windows. And that was enough, I think, to put off my friend from moving to Java, or at least he didn't come and bother me about that kind of thing.
Right.
Obviously, you've just found your first, but it was trivial.
Yeah.
How far down that road do you think you will go? And maybe you won't have as many issues as we would have in like a more trading system focused thing where we have even more weird options and things.
I think the nature of the problem that we're solving with this means that it's very unlikely that we're going to run into something like that, because this project runs entirely in AWS and Google Cloud, first of all.
Right.
So the whole concept of any sort of customized hardware is just like, that's just not a practical solution for us, period.
Yeah.
Right. And in addition to that, one of the things that I've certainly seen is it's not Conway's law, but there's some sort of weird, Conway's cousin's law or something like that, where it's like, the operating system that you develop on affects the architecture of your system.
Yeah,
right?
no, for real.
And so if the model that we have, which we're going to have, is one where we are developing primarily on Macs, occasionally on Linux, and my intention here is to kind of support both for development purposes. But if we're developing on Macs and deploying on Linux, then we're gonna be very reluctant to change the architecture in a way that's not compatible with that model, right? It's not to say that we won't, but there's going to be a sort of pressure to be like, can you just design this so that it also runs okay on a Mac, right? And that means we're going to be doing, so like a lot of what I've been doing this week has basically been taking our very sort of like Ubuntu and Linux specific scripts and tools and bash scripts and things like that. All the places where it's like we've got some path that's got Linux 64 in it and doing dollar uname
dash P or
right.
whatever. Yeah.
Exactly stuff like that, right? And so once we've made that switch, it's sort of like and combined with the fact again that we're running in the cloud anyway, I think it would be very unlikely that we would wind up in a situation where it's like, oh yeah, we've got this weird proprietary binary thing that we have to plug into the middle of this.
I think the key in that is that you're all going to be doing this.
Yes.
Whereas with the situation I was in before, it's like one developer was like, yeah, this would make my workflow really, really easy if I could just do it locally. So I'm going to do it locally. And everyone else is like, well, good luck with that. And then they were like, hey, I've just hacked the code at 6 ways to heaven so that it works on my funny setup. And it's like, no, this is like the person who comes in and like reformats all the code because it looks better in their editor, and you're like, I don't care, no, or whatever, or like every file has like a .emacs RC in it, and you're like, stop putting stop it, nothing against Emacs or VI, but like there are certain things that you don't want to like say, well, there's a tax and a cost that I'm prepared to impose upon my colleagues, and that should be extremely minimal. Especially if it's only benefiting me or a very small subset of people. That's just sort of general. Yeah.
Yeah, absolutely. And I mean, for me, that is a really important thing to do is as a team, decide these are the tools we're going to support as a team. And these are the tools that unfortunately I know that you're, a Vim expert, but we're not going to be writing this Java code in Vim, right?
Right.
And I think it's like a really important aspect of team cohesion is to be able to come together as a group and decide that and really like be okay with it and mean it and commit to it.
That's a really interesting aspect of this, is that whole cohesion around a team that you get around a set of principles, and be those principles as simple. I realize we're going off in a completely different direction here, but those principles are: do we vaguely agree on how to name things? Do we vaguely agree on the code format? Do we enforce it, perhaps? Do we have like bits that are in some formats, bits that are another? Is that okay? Or do we want a unified stuff? Do we use the same tools? Do we allow people to choose the tool that's right for them where it makes sense? Or do we just say, no, you just have to use, Visual Source Save for your code, your source code? And that can make or break a team.
Oh, absolutely.
Yeah. I mean, like I if somebody prior to me choosing to move to the Mac, if someone had told me, as indeed they did at a previous employer of ours, you have to use a Mac for everything.
Mm-hmm.
That's a very big quality of life for me as a developer change. I'm built. I've been built. I'm built to use Linux. Right. That's my
Yeah.
You know. I'm only get away with this Mac because my keyboard has a button I can hit that flips it between the Control and Alt being the wrong way around and the right way around. But as I go
Yeah.
in and out of the Mac itself
Yeah.
and
Yeah.
the Linux machine I'm controlling remotely. But yeah, some of those things could be could break you. I could imagine. Yeah.
Oh, yeah.
Yeah. So you decided this as a team that this is something you're going to go forward with, and therefore it's makes sense. Obviously, you're also the lead, which gives you a certain amount extra vote. But if you made everyone else miserable, you wouldn't have a team anymore. So
Right. No. And I mean, this one is particularly easy. We had someone join our team back in October, and they had come in and they had, gotten their standard issue MacBook, and they had installed IntelliJ on it and all these other tools, and had clearly, like had used a Mac before and really liked it. And it's like, yeah, so show me how to load up the code and edit in IntelliJ. And I'm like, oh yeah, you need to do this on Linux. And I could see her face fall.
oh
and be like, oh, okay. I was like,
oh, so
yeah,
presumably
this
this is again
is.
to give away what time we're recording this. If we're releasing this in what March or whatever, that's a nice Christmas present for her to have. Like, congratulations, you can now edit on the machine that you're running on and use all your keyboard shortcuts and whatnot.
Right. But yeah, I mean, it's not a hard sell for me, and
Yeah.
the other folks on my team are definitely like, oh yeah, no, this is great. And me too, of course. It's like, I've worked this way before. Like it's going to take some time for my fingers to adjust to the keyboard shortcuts, but it'll all work. But yeah, I mean, I think that whole aspect of team cohesion. We've talked about intersubjectivity on this podcast before. It's really hard to have intersubjectivity if you don't have the same tools.
Yeah.
Right?
Yeah.
Like obviously, like the build tools and the testing tools and those things are important, but also just like, oh yeah, when I was refactoring this thing, I extracted this thing over here, and then I clicked this button, and I did that, and someone might be like, oh yeah, no, I wouldn't do it like that. It's like, well, why not? It's like, well, because that would be really hard with my editor.
Honestly, that is really, really interesting. So I on our team, which is a C++ team, that we're about 50-50 VS Code versus C Lion, and VS Code's a fine IDE, but it is a little bit less batteries included, which means it's a lot more responsive. Although C Lion is getting better as well. Obviously there are trade-offs in both, and I find I use both of them for different reasons. But yeah, I do find that like my working environment, when I can just refactor things without thinking about it, when I can put my cursor in a test and say, run the test, please. I mean, it goes, oh, you mean the test that your cursor's in right now? And I'm like, yes. And that's just Control-Shift-F10. And it's so different when I go and look at my colleague next to me who's in VS Code, and I'm like, oh, just run that test. He's like, I don't even know how to do that. And I'm like, is there not a button to do it? And it's like, all right, well, let's just debug it. And he's like, well, I can't. And he fires up GDB in a console next to him. Like, I'm sure there's a way to teach VS Code, and there is, and you can configure it and stuff. But it's like, it's not a one button thing. It's like, oh, you have to create a little bit of JSON that explains what this particular thing's doing. And I'm like, why would I want to write? And all those things, right? And you realize, yeah, we have a fundamentally different development experience, and obviously there are things that are positive about some and the other. It's like you need to be able to know how to run GDB. You need to know how to run these things from the command line. But like, if you can do it in an IDE with a single click, go for it. Like coverage the other day, I was like, I just ran with coverage because there's a button in my IDE that just says, oh yeah, I know the right flags to pass to CMake to make it do all the coverage things. So if you want to get coverage on that test you just ran, and then I'll parse the output and color the lines that way, I just click a button. I love it.
Yeah.
But yeah, anyway, sorry, we digress, which is, well, I mean, this whole thing's a digression. That's the whole point of it. But yeah, it is important to have some commonality.
I mean, I think the more of it
cohesion.
You can get, I value that a lot, honestly. And it's sort of like, I really want the people on my team to agree on the tools that they're going to use and the techniques that they're going to use, and which is not to say we can't change it. We're doing that this week, right?
Yeah, real.
But if we're going to change, we all change together, and we change for a reason that we all agree with and understand. We don't necessarily all love, although in this case I think everyone kind of does, but like being able to commit to it and be like, this is maybe slightly less optimal for me, but it's more optimal for the team and it's more optimal for the company, and therefore I'm committed to doing it.
Yeah.
Right. And I think that kind of consistency and sort of commitment is one of the things that defines what a team is, right? Because they're all committed to succeeding and failing together, right? Like it's much harder to make that commitment when it's like, okay, well, yeah, I sort of see in an abstract way how this helps the company, but like at the end of the year, they're going to be looking at what I did and they're going to be looking at what these other people did and they're going to be comparing them in different buckets.
Yeah.
And it makes it really hard for me to be like, all right, I guess I'll just use this thing that I'm not very productive in, right? And take the time and energy that it takes to learn how to
That
do
is
it
a
well,
fascinating observation.
right?
Yeah.
So like, you need to have people who succeed and fail together in order to be able to have this cohesion. Otherwise, I find it to be very sort of difficult to maintain. But if you have it, then it's like, someone joins my team and it's like when you're working in Java, you're going to be using IntelliJ. Full stop.
Right.
Like there's no option here, right? Like that's how all the tools are set up. That's how all the techniques are set up. That's how the whole environment is set up. That's what you're going to use. And if you don't know how to use it, that's fine. You'll learn.
Yeah.
Right?
It is. Yeah. No, that's cool. The whole team cohesion and succeeding or failing together is very interesting. A lot deeper than I was thinking when you were just basically going to say. You said to me before we started recording, I got my Mac. Let's talk about why I got my Mac. And then here we are, and I'm like, wow, I've had such a moment of like what feels very affecting an insight into like what makes a team is like, yeah, we're in it together, and that means we either succeed together or we fail together. And we only succeed if we choose JetBrains products. Is that what you're saying? We're not sponsored.
Not sponsored
by JetBrains. Although you will find my ugly mug on the
sea lion. Right.
Sea lion
JetBrains is sponsored by you.
That's right. Oh dear. Yeah, that is funny. So anyway, you've got a Mac. I've got a Mac. They're impressive pieces of engineering.
Oh, they really are. They really. I wish I knew. I honestly wish I knew more about like sort of what went into it and the architecture of the chip and everything.
I do too. I mean, we have a mutual friend who is very secretive and works for Apple and keeps hinting at the amazing things that he's doing. I don't think it's anything to do with this, but it like just gives you the idea of like what level of thing can go down in a big company like Apple, like the amount of engineering effort that they can focus on something. Like essentially ground rebuilding a processor. They, as far as I know, they licensed the architecture for ARM, but nothing else. They this is like essentially it's like paying for getting the VHS compatibility or the DVD sticker that says this is a DVD this is DVD compatible. But you're I don't buy any of the parts from like JVC or Toshiba or whoever. I've built one from scratch and from like literally from the component up. It's compatible with ARM chips, but it's not made by ARM, and I don't use any of their blueprints. I didn't license their blueprints. I didn't buy any of their pieces or their intellectual property. I just made my own ARM chip. It's like the most bonkers thing to do, and that's because they believe strongly that they could do it better than ARM could.
So, and I was going to ask you about this because of all the people that I know, I figured you would be.
I know
understand it
a little
better than anyone else that I could.
Well, yeah, but I just mean to say,
I'm
sure our listener is screaming into their headphones now, going headphones.
Right,
yes.
It doesn't work like that.
No, exactly.
But so it's. I sort of was confused because when I heard that Apple was building their own processor.
Yep.
I also heard that it was an ARM processor.
Exactly.
Like, well, wait a second, isn't there a company that does that? And so what you're saying is that they basically license like the opcodes.
Effectively, yes. The architecture is copyrighted, if you like, and they license that, and it says that like if we emit bit streams that look like this, we will interpret it this way, and that means that it's that's what ARM is. Now ARM do license and sell you. So ARM have never physically made chips themselves. That's not what they do. They've always been IP based.
Okay.
So they have always essentially they give out the plans to the ARM chip. Back when they were part of Acorn, they were just making it for themselves, right? They had written Verilog or VHDL or whatever they've written the processor in, which is like a completely bonkers thing to even say out loud. The processor is written in code, which it is.
Right.
The result of compiling that is literally the floor plan of where all the transistors go, and then you get your essentially multi-level SVGs of each layer, and you send them off to the fab, and the fab, I mean, this is extremely simplified and not quite right, but the fab takes each layer, and then they just burn it one after another onto a layer of silicon with all sorts of clever washes of things and bombardment in between to like layer on all the different bits and pieces, and then you get back a chip. Hooray! But you didn't make that chip, you just had the design for the chip and you gave it to them, which is that's fine. That's how most people do this. Now, Intel do actually make their own chips, right? I don't know. Actually, I'm not sure AMD do, but this is why. Partly, this is why the whole Taiwan thing is such a big deal, because almost everyone who isn't making their own chips goes to TSMC, which is a Taiwanese company that make the world's chips, and for all the political reasons, that's kind of a problem for some places. For the US in particular, they've realized that if all the chips that are being designed in the US get sent to one place a long way away to be made and then come back, and they're hopefully the same thing that you sent them out as, then that's maybe a problem for security, like if your military is really depending on. Anyway, we're getting completely off track here, but so ARM have always sold intellectual property. You could license the chip from them, and they would say, here's the source code to the chip, and here's some like areas that have been pre-laid out if you like, and then you can go and edit the code yourself. And so that's how the various manufacturers for all the system on a chip places are like, oh, I'm going to add on like analog to digital converters. I'm going to add embedded RAM, and then I'm going to send that off to the fab myself. And then they're going to come up with an ARM that has 2 megabytes of RAM on it and an army of analog to digital converters and all this kind of stuff. And now you've got a Raspberry Pi, right? That's the kind of thing that you're doing. Again, I'm probably missing. In fact, I am getting it completely wrong. But like something like this. And then, but so those companies that were producing ARM machines were likely using some of ARM's reference implementations of their chips to go to market. So what you think of as an ARM chip, like inside my Android phone I'm holding up to the camera right now, oh crikey, now I can't remember the name of the chip in it, but the Cortex or whatever it's in it, has been probably come from ARM, modified by whoever's manufactured it, and then sent off to be fabricated. Whereas my understanding is Apple have gone, that's nice and all, we're going to do it from scratch. We're going to build it from scratch. Like it'll be compatible.
Right.
And in order to be compatible and for us to say that it's compatible, we need to license it for all the reasons, which, I mean, I've no idea how absurdly expensive that idea is. Like we're doing it all ourselves, but in order to call it a car, even though we haven't like licensed a car from anyone else, we have to pay all this fees to the car manufacturer, and then it's got 4 wheels that we built ourselves. It's just, sorry, I'll keep switching analogies here. But they've done an amazing job. It runs so fast, as you've discovered.
Yeah.
It runs cold. We're doing video conferencing at the moment, you and I've got my hand on top of it, and there's no fan that I've ever heard come in on it. It's absolutely amazing. I mean, right, okay, small nerd thing here.
Yeah.
So ARM chips have always been extraordinarily power efficient. It was never really, I believe, the intention that would be the case, but they observed that their design was very low power. And the legend is that the very first ARM chip, the ARM1, that was delivered to Acorn in, I guess, the late 80s, or sometime in the 80s, they plugged in, and it was plugged into a BBC Micro, of course, because that was how this thing was going to go down. And they'd written a bit of code to print out Hello World, and so they connected it all up, and they turned it on, and first of all, it worked first time, which is miraculous, right? The fact that the board comes up and it just worked first time, and the little Hello World got print across like the parallel port, or the tube, the connector that came from it. And then, having celebrated the fact that it worked first time, they realized they hadn't plugged it in yet. And that caused an awful lot of confusion. The power rails were not connected, but the parasitic like all of the other things that were plugged into it for like the clock and all of the other bits and pieces were enough to power the circuitry. Because it was, and they were like, oh my golly, this is super how low power is this when it's like hasn't been fully plugged in and it's still there just because it's plugged into a secondary computer that's like reading the lines and stuff. So
that's incredible.
And again, I've probably butchered that story as well. Again, comments welcomed to correct me in the appropriate places, but yeah. So ARM have always been efficient.
Wow. That's, I mean, I was going to say, like, one of the great things I've noticed about my MacBook is that the battery life is ridiculous. And I kind of had this, I also have an iPad, which is an M1 chip in it. And I think I basically never charged that iPad. Like I bought it like, a year ago. I don't think I've ever
it's just been slowly 1% every 3 or 4 weeks goes down. And you're like, yeah.
Fine. Apparently it's absorbing energy from the surrounding
Maybe it is.
Or something.
Maybe it is. It's like one of those really high-end wristwatches that are, like self-winding by the very motion itself.
It's incredibly, incredibly efficient. So it's like, and that was actually one of my complaints with the Dell laptop that I had, is that it would really chew through the battery. Like I actually had a few times where I took it like over a weekend, didn't plug it in, and I would come into work Monday morning and the battery would be dead. And it had been sleeping the whole time, but even the sleep power draw was so much that it couldn't last.
Yeah,
for more
I've
than
never been that
48
sure
hours.
about how good Linux is at putting it into sleep mode
true.
as well. There's so many. There's this delicate dance between the BIOS and the operating system for negotiating which bits of RAM to keep powered up and which bits not to, and things like that, and then when to wake it back up again, how to wake it up. I remember, the having to go into a BIOS on one of my Lenovo's and sort of have to put it into legacy mode so that it could talk to Linux rather than Windows, which of course is the default for these things.
Right.
So who knows who's really to blame there. But no, it's definitely the case that with my Lenovo, which I use for my personal stuff, that I'll often have it on my lap in the other room, and then I will find my lap is on fire because something somewhere is taking up all the CPU, and I don't know what it is.
Probably Chrome.
Yeah, that is a fair point. Yeah, Chrome, which is not really Chrome's fault either. It's also the 330 tabs I have open.
Well, yeah.
One of them is possibly, doing something stupid.
Right. Like still in the Google Meet from 2 hours ago.
That's right, yeah.
It's like showing the conference room video and the audio.
Yeah. Yeah, it is
like, oh, right, I should probably quit
It is worth, just taking a moment, and we should probably stop in a second because we're getting to time here. But like, I'm currently looking at you on a screen, on a 4K monitor. You're several miles away from me, and Magic is both compressing the video on my side and sending it to you, decompressing your video that's been sent to me, then compositing it into a window on a 4K monitor. I have another 4K monitor next to me that has like a waveform of this recording going on. And I know that if I pick up my mouse and grab the window, I can move it around essentially at 100 frames a second. Right? There's not any lag between the movement of the mouse and me moving this picture of you around. Right. And you just have to think how much data is being moved around whimsically by me, like wiggling the mouse by holding down the like, oh my gosh, I remember rendering an MP3 audio file to an uncompressed format so I could listen to it because my computer wasn't fast enough to decode MP3.
Oh yeah.
And yet now I get annoyed when there's like 18 people in a room, in a meeting room, and like sometimes it drops out a bit or the fan comes on and I'm like, oh really? Do we have to? I'm decoding like 12 different video streams and compositing them, and I'm running Chrome in the background. Oh, we're very blessed. We live in a blessed time for this kind of stuff.
Or you could also say spoiled. That works.
That works too. Yeah.
It's sort of a weird variation on risk compensation psychology, which is another thing we've talked about in the podcast. It's sort of the whole thing of like, as you have more safety mechanisms, people just use those, and the level of safety that they actually achieve remains constant because they just do more dangerous things
because they have a seatbelt on and now they drive faster. Right.
Yeah, and it's the same thing with computing power. Is the more of it you give people, the more of it they're going to use.
Well, that's.
Right?
I mean, we definitely don't want to start a new topic now, but we had a dinner table conversation with my family the other day about exactly that. That with the idea like all apps nowadays are Chrome repackaged as a binary running a JavaScript program that's communicating with a DOM that's being rendered and then drawn back to the screen rather than using like the operating system widgets that would do it kind of natively. but it's convenient. Why
Yeah.
would you spend all this time to squeeze everything down into 512K of RAM or whatever one used to have to be able to do something?
Right.
When you're like, just make an array of big enough. How big is big enough? I don't know, 4 gig. You don't really think about it. It's like, that's fine.
Yeah.
Well, I guess we should call it at that point.
Yeah.
Otherwise, we're going to have the longest podcast ever. I guess it's not
I'm
too
gonna
bad.
go back. It's not too bad. I'm gonna go back to converting my bash scripts, calling uname in all the various places. Actually, so one of the interesting things that I think is going to fall out of this is I'm actually going to shift more stuff into AWS that used to run locally.
Oh,
Because I
interesting.
sort of have this problem now of like, okay, if these things are running on the laptop, then as you were saying, like we normally have this stuff like very, it's running in a data center.
Yep.
The workstations are actually in a data center, and so you have nice internet connectivity and access to all these things. And it's like, well, if I'm not going to have that because I'm running on the laptop, then I'm going to be doing a lot more remote execution in AWS in lieu of doing it locally.
Yeah, rather than
because
like
locally
trying to
is
pull
much more
down.
local than it used to be.
Yeah.
Yeah.
That makes sense.
So I'm going to go back to that and hopefully get it done today.
Well,
yeah, cool.
good luck with that, Ben. And
Yeah.
I guess I'll chat to you, I was going to say next time, as if we
Yeah.
don't talk to each other in between these podcasts.
Yes.
Well, as we've alluded to several times, it's about to be Christmas. We're at the end of the year here, so happy holidays to you, and I'll see you in 2024 when this podcast comes out.
Right, exactly.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.